Hi, in this lecture video, I'll be discussing the synthesis of alcohol. So how do we make our alcohol functional groups? So I'll be discussing 4 different types of reaction of what we can use to make the alcohol. So they are the following. So overall, there are 4 reactions that I'll be covering in the next several lecture video for that will cover the synthesis of alcohol. The first one is the nucleophilic substitution reaction that we have learned already. Nucleophilic substitution reaction. And the second types of reaction that can also be used to make the alcohol that we actually have covered already would then be the addition reaction. And this is also known as the hydration reaction because there are many types of addition reaction. The types of addition reaction to make the alcohol would then be the hydration reaction. And again, we'll discuss that in a little bit. On the next several lecture video, I'll be discussing the other types of reaction that can also be used to make the alcohol, which I'll give you in introduction at this point, would then be the reduction reaction. We can make alcohol by performing reduction reaction. And then lastly, the 4 types of reaction. So this is the types of reaction right here that involve the use of the organometallic reagent. So organometallic reagent. They can also be used to make the alcohol. And again, we'll see those reactions on the next several video. In this video, we will focus on the nucleophilic substitution reaction and the addition reaction or the hydration reaction of alkene to make the alcohol. Now, these are the reactions we have seen already. So alcohol can be prepared by substitution reaction in which the leaving group is then replaced by the hydroxy group. So if we were to have an alkyl halide or any other types of functional group in which we have a good leaving group, then essentially we can react this with the hydroxide, where that is acting as a nucleophile coming to replace this extra here to then become our alcohol. And for an example, if we were to have a primary alkyl halide, so here in this case right here, with this functional group, we now having the chlorines as the leaving group. And when we take this and react in this with sodium hydroxide in the presence of a polar A product solvent, so this is an A product solvent right here, it will undergo an SN2 reaction to then form our alcohol. So that's one way. And we can also have a tertiary substrate as well. And in the case of a tertiary substrate, by taking this reacted with water, and again, water is where we have the sources of the OH group, and it will now undergo an SN2 reaction. SN1 reaction to now also produce our alcohol as well. So again, substitution reaction is a very, very common types of chemical reaction that we can use to make our alcohol. We just have to make sure that our nucleophile have the source of OH group in it. It can either be hydroxide or it can also be water by either undergoing SN2 or the SN1 reaction. And the other types of reaction that we have already discussed as well to also make the alcohol would then be the addition reaction of alkene. If we were to have an alkene by doing the hydration reaction, so this is basically known as the hydration reaction of the alkene. And we can also do hydration in the case of by you do an acid catalyzed hydration to make our alcohol. And we can also do the oxymercuration demercuration method right here to also make our alcohol as well. And we can also do the hydroboration followed by oxidation method to also make our alcohol as well. And please note of the differences. So here in this case right here, the alcohol that we'll be making in case that we use acid catalyzed hydration, this would then be the Markovnikov addition, right? So this is the Markovnikov products. And when we use the oxymercuration and demercuration method, this would also produce the Markovnikov product as well. But the advantage of this is that there's no carbocation rearrangement, but both of these are the Markovnikov products. And lastly, with the hydroboration and oxidation method, we are now producing the anti-Markovnikov product. Versus all of these are the Markovnikov. So Markov stands for Markovnikov. But that is how we can change an alkene into the alcohol. So these are some of the examples right here. We can take this and convert this into an alcohol. So what reagent will we have to use here? So here in this case right here, we have a tertiary substrate converting into the tertiary alcohol. So here in this case right here, we have to use an SN1 reaction, and that can be done with water. And as for this reaction right here, so in this case, to change this alkene into our alcohol, and now we have a primary alcohol. So in this case right here, this is undergoing a anti-Markovnikov addition. So therefore, we have to use the BH3 and THF, so the hydroboration followed by oxidation method. H2O2 with sodium hydroxide. So this reagent right here will give us this primary alcohol. And again, this will then be the anti-Markovnikov products. And in 13, to convert this alkene into this alcohol, we will then see that we have to do a hydration reaction. But which types of hydration reaction do we need? So here in this case right here, the product here is the Markovnikov product because the OH group is added to the more substituted carbon. So we'll have several options, right? We can do acid with using sulfuric acid and water to do this reaction. We can also do the oxymercuration demercuration method as well, but that would not be necessary here in this case, so we don't have to worry about carbocation rearrangement. And lastly, here in this reaction right here, 14. So we are doing a Markovnikov addition to make this alcohol right here. And again, we know that we have to do the this in the Markovnikov product. It is because the hydroxy group is then added to the more substituted alkene carbon. But here in this case, there is a possibility for carbocation rearrangement, and we need to avoid that. So therefore, if we were to do acid catalyzed hydration here, it will undergo carbocation rearrangement where the hydroxy group would then be added to this carbon right here. And that would not be ideal. So we have to prevent the carbocation rearrangement here in this reaction. So therefore, we have to use the oxymercuration and demercuration method. So the reagent would then be involving mercury acetate and water, and followed by the next step, the demercuration using sodium borohydride.